record on this computer. Right, so let's get started, and we are looking at exactly this question. We're looking at 1.1.1. Right, so we are practicing together, and I'm starting from the basics. And we're looking at x squared plus twice
I mustn't
x.
write anything.
You mustn't write anything. Mustn't write anything because you won't keep up with the pace, you know? Right,
Okay.
so yeah, so now you are watching and factorizing this. Right, what are the factors of x squared? They're x and x. What are the factors of minus 15? That give plus 2. Those are exactly plus 5 and what? And minus 3. Right, so we know that, and that's very obvious. And what are then the solutions to this? Right, so we're able to see, therefore, that the solutions are x equals minus what? Minus 5 or x equals 3, okay? So those are the solutions. The next thing when I look at, set ready, you don't need to copy anything, 1.1.2. Right, you'll copy at home because I'm gonna send you the video. Okay, you can copy after this. Right, so we're looking at the next one. And the next one is 1.1.2, which is exactly 5. Right, 5x squared minus x minus 9 equals 0. And then now, how do we solve this? Obviously, the examiner says correct 2 decimal places, which means x equals minus b plus or minus the square root of b squared minus 4 ac all over what? All over twice a.
True.
Yes, this is equal to what is minus b. So minus b is going to be minus 1 plus or minus the square root of the following. Right, so we have the square root here like this of the b squared, which is minus 1, which you square minus 4. What is our a? Our a is 5. What is our c? Is minus 9. And you divide every single bit of thing by twice. A is 5, like that. Okay, so we have that. From which we're able to see, when we simplify this, that we have the result. So which means x is equal to, okay, simplify everything. So it becomes 1 plus or minus under the square root. You'd have exactly 181. So 181, and you divide everything by double, which is 10.
Right.
Yes, 2 by 5 is 10. Right, so you have that. So what are the answers to this? Now there are 2 results at the end of this. So if you use a calculator, you'll be able to see that if you choose the positive one is going to be 1,45. And the one with the negative is going to be x equal to minus 1,25. Okay, so you're able to see my screen, is that right?
Yes, sir.
Okay, yeah, it's a different platform. I'm also using something called OneNote. Okay, right, so we have this. Now, this is exactly what we have. The next question we're going to do is actually 1.3. All right, so 1.3 can be done with these. I said I'm going to send you the video, so you don't need to copy anything. Right. So 1.3. What is 1.3?
So,
yes?
Can you see me?
Please come again.
Can you see me?
Yes, I'm able to see you.
Okay.
I'm able to see you, but it's just that I made it such that you can't see me, right?
Oh, okay.
You cannot see me. Right? Is that correct?
Yes.
Yes, I made it on purpose. I could make it.
Okay.
I could make it such that you're able. But now make sure that you make your screen large. You expand your screen so that it feels like the whole screen of your device. All right. Yeah, I made on purpose that I'm not visible. I would make it, I would make myself visible, but I'm not fond of that. Right. So at this point, right, because this is going to be recorded and it's going to be there on YouTube, you see? All right.
Okay, so
So yeah, you have the x squared minus 3x, and then I'm pulling out the common factor, which is going to be x minus what? X minus 3 is less or equal to 0. Okay, now, what is this? What is this? Right, so now we continue with this and we're able to get the result. What are the factors of this? There are certain things we call the CVs. The CVs. What are CVs? CVs,
critical values.
yes, critical values. What are the critical values of this? So the critical values are x equal to 0, x equals what? X equals 3.
X equals
So
3.
yeah, at this point, you're able to see, therefore, that this is exactly this. So now when x is less or equal to 0, equal to 0, okay, this is exactly the x-axis, and equal to 0 is here and there and there. But we are saying less than 0. So less is actually this part of the graph. Okay, right. So when is this less than 0 or equal to 0? So it's less or equal to 0 when x lies between 0 and what? And 3. All right. 0 and 3. So that is exactly the result there. If you don't want to say that, you can say or x an element of the interval from what? You're starting from 0 to 3, and then you close like this. So so what is the next thing now? Right, so you have this. We want to also now look at 1.2.1. Right, so to now look at 1.2.1, we're able to see therefore that 1.2.1 is, you need to solve for a when you're given a plus 64 over a is equal to 16. In which case you multiply through by a. So if you multiply through by a, you'd have a times a plus a into 64 over a is equal to a times 16, which is exactly a squared plus 64 is equal to what? Is equal to 16a. And then this is exactly a squared minus 16a plus 64 is 0.
Isn't it minus because it came from the other side? Oh yeah, it's right. Sorry, sir.
All right, I'm happy that you agree. You agree, right?
Yes, sir. Sorry, sir.
Okay, that's fine. Right, so what is the next step out of this? All right, what is the next step out of this? Right, we're able to see therefore that we can find the factors of this. So what are the factors of a squared? A and a of 64, 8 by 8, but both negative, because negative by 8 by negative 8 is what is 64. But minus 8 is minus 16. So these factors are correct. Right, from which we're able to see, therefore, that a is equal to 8 or a is equal to 8. So those are the, so we've solved for a. We've answered question 1.2.1. Right, we solved for a for 3 marks, and a is 8 or a is 8. Okay, so you have two equal roots, Right, so the next thing to do now is to look at this one for another 3 marks to say hands. If the examiner says hands, they mean you need to use what you got above. Right, so what you got above will be what? It's exactly what we have there. Let's do this now. Let us do this. Right, so we're gonna look now at 1.2.1. Right, so in view of 1.2.1, we're able to proceed. We're able to proceed. Okay, so 1.2.2.
So say,
Yes,
so
please.
say, let's talk. So from now on, we're gonna use online lessons.
Not really. Yeah, we're gonna use both. But I
We're gonna
just,
use both.
yeah, we're gonna use both the board and online.
Oh,
Yeah. So there are times I'm gonna use the board, there are times I'm gonna use online. But obviously I know that you already understand online. So you see, the person we need to just train is Bopilo, you know, we need to just make sure that she can do the online just in case, but obviously data can only be the problem, I'm sure. And
yeah.
that, yeah, that would help in the event that you are lazy to walk the distance because it's a bit far, you know. Sometimes I feel your pain if you're supposed to come all the way from Orlando to here, you know. And
Yeah,
so
you must make sacrifices.
I understand, yeah, you make you sacrificing. So yeah, so I'm
Mm.
gonna use a mixture of both. Okay. So I'm gonna use both
Mm.
online and what? And face to
And the
face. We
board.
call it face to face.
Mm.
Yeah. So or the physical ones. Right. So, but obviously this one is a pilot program. So it's being piloted. Right. Now we are looking at 1.2.2. Right. We need to solve for x. And what are we given? We're given 2 to the power what? 2 to the power x plus 2 to the power 6 minus x is equal to 16. So what is this? And can we be able to solve this? Well, the answer is yes, but the examiner said hands. So it means we're going to use the above result. So this is 2 to the power x plus, all right, so this is exactly 2 to the power 6. Because now you can break the 2 to the power 6 minus x to that. So that you have 2 to the power x plus, and then you have 2 to the power 6 divided by 2 to the power x is equal to 16. And this is exactly 2 to the power x plus, what is 2 to the power 6? It's exactly 64 over 2 to the power x is equal to 16. Right, this realization is very important for us because it's exactly what we got at the bottom. It's exactly what we got at the bottom. What did we get at the bottom? We got at the bottom that, so if we let a be equal to 2 to the power x, what will then follow? It will then follow that 2 to the power x, we got that 2 to the power, a was what? A was 8. So 2 to the power x is going to be equal to 8. So, but 8 is what? So which means, therefore, you have 2 to the power x equals 2 to the power what? 2 to the power 3. Right, so if it's 2 to the power 3 like that, which means x is equal to 3. So x is 3. And x is 3, and that is, yes.
Sir, you're
Yes,
moving
please.
too fast, sir. Can you go back, please?
Okay, that's fine. That's fine. I'll go back. Right,
Mm.
let's start from the beginning. Right. Remember that the question came from here. Is actual question 1.2.2, which is 2 to the power x times um plus 2 to the power 6 minus x is equal to 16. So I've copied the question in red, first step. Then I realized that I had 2 to the power 6 minus x. I broke it down to 2 to the power 6 by 2 to the power minus x equals 16. Then you have 2 to the power x plus 2 to the power 6, and then you divide by 2 to the power x because of the negative exponent equals 16. Right, so at which point you're able to see, therefore, that you have 2 to the power x plus 64 divided by 2 to the power x, which is equal to 16. Because 2 to the power 6, what is 2 to the power 6? 2 to the power 6 is equal to what? Is equal to 64. Okay, so you just note that. From which we're able to see, therefore, that you have that 2 to the power x is equal to what? Is equal to 8. Right, when 2 to the power x is equal to 8. Why is 2 to the power x equal to 8? Because we got at the beginning, or rather here earlier, we're able to see that a is equal to 8. But we can see that this equation is exactly the same as this one. It's exactly the same as a plus the one we solved in 1.1.2, the a plus 64 for a equals 16. It's exactly the same as the one we got. So, but now it's just that a has been replaced by 2 to the power x. Wherever there is a, there is what?
There's
2 to the power x. Right, you agree? Right. So,
Yes.
which means in the place of 2 to the power x, 2 to the power x is equal to what? So 2 to the power x is equal to a, which means 2 to the power x is equal to 8. Why is 2 to the power x equal to 8? Because 2 to the power x is a, and a is what? A is 8. Right, good. So we have 2 to the power x equals 8. Right, 8 is 2 to the power what? 2 to the power 3.
No, okay.
Which means that when the bases are the same, we equate the exponents. Right, we equate the exponents or we equate the indices. Right, meaning that x is equal to what? X is equal to 3. Right, so it follows therefore that x is 3 as it was to be found. Right, so the next question is 1.3. Let's look at 1.3. 1.3 is very, very simple. Right, it's very simple. Let's look at 1.1.3. What are we supposed to do in 1.1.3? Right, so now, right, so we have 1.3. Right, 1.3 is very, very straightforward because we are given in 1.3 the square root. Right, as I said, I'm going to use both the board and I'm bringing a bigger board now. Okay, I'm bringing a what? A bigger board than that one. All right. Right, so we have 1002 plus 2 to the 1006. And then you divide by 17 into 2 raised to the power 998 to the power 998. Right, so we have this. Right, so now we have this. So now with this, so what are we having? We have something to simplify, and then now we can pull out a common factor. What is the common factor? The common factor is 2 to the power 998, which can be factored out from the numerator. So in the numerator, we have 2 to the power 998, which is 2 to the power 4. Okay, because now if you pull out 998 from 1002, 1002, yes, so it's 4 left. Okay, and then now we have, what is 1000? Yes, what is the top one? Right, the top one.
It's
Yeah, you pull out 998 and then you are left with what? You are left with what? Be 8.
2, yes.
Because we're saying 1006 minus 998, right?
998, yes.
So it's like it is going to be to the power 8 like this.
Yes.
Okay, good. Anyway, so we divide everything by the following, right? We divide everything by 2 to the power 998 into 17. I said already, I use all these things of learning. I use online. I also use, we call it face-to-face learning. Right. So now, what do we have there? What do we have there? So now what we have, is that it is exactly precisely that one. So we can pull out another common factor from there, but we already have a 17 in the denominator. 16 plus, all right, 16 plus, and then this one is what? What is 2 to the power 8? All right, because it's a bit large, what we can do is the following. You can pull out 2 to the power 4. You can pull out 2 to the power what? 4.
It's
That we have 256, I would imagine, yeah. Right, so because it's a bit large, we can pull out 2 to the power 4 out of the what? Out of the numerator, which is 2 to the power 4. 2 to the power 4 is what? Is 16 into 17. Okay, there's 17, which is coming from 2 to the power what? 17, which is coming from 2 to the power 2 to the power 4 plus 1, it's 17. That's already, I'm using many ways to learn, to teach. All right, so I'm not relying on only one way of learning. Right, so now you divide and then it is 16. The square root of 16 is what? It's 4. Okay, all right. So that means the answer is 4. Just learning how to do this one. And we're recapping on the basics as well. All right, so the next thing we're going to discuss is how do we deal with simultaneous equations? How do we deal with simultaneous equations? Let's deal with simultaneous equations. Right, so how do you deal with simultaneous?
You create 3 equations.
We create 3 equations. Well done. We create 3 equations. Okay, I'm glad you're able to relate to that, Senator. So we're dealing with 1.4. And first equation is exactly 2x minus y is equal to what? Is equal to 2. We can call it equation 1. The next equation is what? The next equation is 1 over x.
1 over
Right, it's actually 1 over x minus what? Minus that, right? So it is 1 over x
minus
3y is equal to what? Is equal to 1, and this is equation 2. So we need another equation 3 we can obtain from the first equation, making y the subject. So it is 2x minus 2.
Yes.
So what we do is you put 3 into what?
Into 2.
Into 2. Done. Put 3 into 2, which means that would have 1 over x minus 3. What is 2? 2 is y, there 3y. So it's 2x minus 2, which is 1. Okay, we get this. After this, we're able to see. Let's say we're going to be using both one line and face to face. Right, so we have this. Right, so what do we get out of these here? Right, what do we get out of these? We're able to get, I want to remove this here. I have this, that is just stuck on my, for some odd reason. Can remove it, let me see. Okay. I'm going to remove this mark, and that mark is just stuck. Okay, that's fine. All right. So now let's just continue. All right, dealing with this simultaneous equations. So this one is what? Right, so you multiply through by the x, and you have 1 minus 3x into twice x minus 2 is equal to x. So I multiply through by the LCD, which is 1 minus 6x squared plus what? Plus 6x is equal to x. 1 minus 6x squared plus 6x is equal to what? Is equal to x. From which we're able to see that you have 6x squared. If you transpose this one across, it becomes positive. Then what is x minus 6? Minus 5. X minus 1 equals 0. All right, let's just continue with this one and see how far we can get. Simultaneous equations. So what are the factors of this? What are the factors of that? The factors of the 6x squared minus 5x minus 1. What are the factors? So the factors are exactly 6x plus 1. And also what? X minus 1 equals 0, which means that x is minus 1 over 6, or x is 1. After we got this.
So can I ask something?
Yes, please.
You see here by the before you multiply through by the
By the
LCD.
x. Yes, by the
Yes,
LCD,
but
because I multiplied through by the LCD, and
yeah,
the LCD.
that equation there. Yeah. You see that equation there.
Yes, yes.
What if I took the x and I took it that side and I times it, because it's dividing by 1 here, and when you
Yes,
transpose it to the other side, it's gonna times. So I take it that side and I
yes.
times it by the 1. It's gonna give me x, and then I carry on as usual. Would it still be right? You
Um,
get what I mean?
yeah, if you take it to the other side. Okay, let's explore what that means, because to me it can mean many things. All right. Let's just explore what that means. Okay, you take it to the other side, the 1 over x, right? Okay,
Yes.
right.
Not the
Because
whole 1 over x.
you take what? You take only
X,
x.
you multiply it that side because it's dividing here. So
Yes.
you take it that side to multiply.
You take it to the right-hand side to multiply.
Yes, because it's dividing on the left-hand side.
Okay, so if it goes to the right, it's going to multiply.
Yes.
Yes, okay. You see, anyway, I'll have to look into what you're saying very carefully to make sure I understand. But my point is, what is permissible in mathematics? I mean, there are many ways to do that. Okay, let me first explore what you're saying, because I'm going to just be doing the same thing here. Right. You see, one thing that is appropriate is to transpose the 1 over x. Okay, we wanted to take only x, but normally we must take the whole term, like 1 over x. And I've taken like the whole term, like 1 over x, and I've taken it to the right. And then this is still correct.
No, it's still correct, sir.
Well, it's still correct. Yeah, I mean, we can take a term to the other side of the equation, you know? A term can be taken to the what? To the other side of
Other
the
side of
equation. Yes. So after we've taken it from the left of the equation to the what? To the right of the equation.
right.
Yes. You get the point. So that is
Yes.
permissible. But it will lead to this, that x is 1 or x is what? Minus 1, 6. Okay. Yeah. Okay. Now, with this, then we need to get the other answers. What are the other answers?
You must transpose. You must substitute
You must
the
substitute. So
answers
we're going to
correct.
substitute. Well done. So we're going to substitute. So y is twice x minus 2. What is x? It's easy to substitute 1. And then we get 2 minus 2, which is what? 0. So one value of y is 0. And then now we also have another value of y. What is the other value of y? For example, so you'd have that y is equal to, okay, this color is too faint. Let me put it at second dot. Right, okay, it's fine, but it's too faint. So I'm going to use green. Right, so which means y is into, what is x? Minus 1 over 6 minus 2, which means y is minus 1 over 3 minus 2, which means you have minus 1 minus 6, which is minus 7 over 3. So those are the answers. What are the answers? So the answers are as follows, right? So we have that you have the minus 1/6, you have the 1, you have the 0, and you have the minus 1 over 7. So these are the answers that we basically need, okay? And we have solved the Simultaneous equations. Right, next question. The next question will be question 2. And we're tackling that one on number patterns. Let's see what we have. Right, so the number patterns themselves are of great interest to us. The number patterns are of great interest to us. And now we are focusing on question 2. Right, question 2. Right, so we are looking at question 2. Right, so we have 2.1. The first term of the arithmetic sequence is -1. The seventh term is 35. Determine the common difference of the sequence for 2 marks. What is this and what do we do here? Right, so it is true that what they're saying is that the first term is -1. And the seventh term, right, the minute they mention the seventh term is 35, it means Tn is a plus n minus 1 into what? Into the common difference, which means the seventh term is a plus, then you put 7 minus 1 into d, which means T7 is a plus, 7 minus 1 is what? Is 6d. Okay, this seventh term is equal to what? Is equal to 35. Okay, then determine something. The common difference of the sequence. The common difference of the sequence. What is the common difference of the sequence? Right, okay, so we have equations. These are like simultaneous equations. So this is like equation 1, and the next one is equation what? It's equation 2. So at this point, we substitute. Okay, we're looking at 2.1.1. At this point, we substitute. We substitute equation 1 into equation 2, which means therefore you have -1 plus 6t is equal to 35, which means you have 6t is equal to 36. You divide through by 6. What is 36 divided by 6? Is exactly 6. So obviously we're to find the common difference of the sequence. And therefore we have that the common difference is exactly what? It's exactly 6. Okay. The next thing is now they're saying the number of terms in the sequence. If the last term of the sequence is 473, right, now you need to find number of terms in the sequence. If the last term of the sequence is 473, yes?
There's Bupilo, sir.
Oh, is she there?
Yeah.
All right. Yeah, there's one chair. Let her sit down, and then I'm gonna switch to her as well. Okay, I'm gonna switch to Bupilo very soon. I'm just finishing with you now, and then I'm gonna switch to Bupilo. Okay. Yeah. So just a few minutes. I'm gonna finish question 2, and then I'm gonna start with her as well. Yes. Now. Let's just finish question 2, and then I start with And then I start with her. Okay. All right. So now let's discuss something here. Right. I'm gonna come and make you guys juice in the kitchen. Okay. I'm gonna come and make you. I'm gonna make you juice, guys, in the kitchen. Eh? Right. I'm gonna come and give you guys biscuits. I'm gonna come and give. Yeah. I'm gonna come.
Oh no, just when the way to Cruella.
All right. I'm gonna come and make you guys juice, then give you biscuits in the kitchen. I'm coming when I'm done with question 2. And then I'm gonna start with Pupilo. But first things first, let us just what? Let us just do this with Tenulo. Right. I want us to look at 2.1.2. And then 2.1.2 Tenulo is an interesting one. It's based on these number patterns in the sequence if the last term of the sequence is 473. 473. Okay. Right, so we found the common difference and then we just need to do the next question. So I'm just gonna continue. Right, so now, right, 2.1.2. Right, so when we're speaking about the number of terms in the sequence, if the last term is that one. So at this point, we are dealing with Tn. The last term is like the nth term. So it's this D. So the nth term is 473 equals, what is the first term? It's -1 plus n minus 1 into the common difference. What is the common difference? We found the common difference to be what? We found it to be exactly 6. Right, so at this point, what do we get? You move the -1, it becomes positive, and then upon addition, it gives us 474 is equal to 6n minus 6. If you just distribute, you open up the brackets with the 6, and then now this is exactly 6. And you add the 6, it becomes 480. You divide through by 6. What is 480 divided by 6? Which means it is exactly what? 80. Right, good. So we have therefore that at this point, we have that the number of terms n is 80. So there are 80 terms. Right, so and then now you have 2.1.3. Right, the sum of the first 40 terms in this sequence. The sum of the first 40 terms in this sequence. Right, so now let's deal with the sum of the first 40 terms. So the sum, okay, this one is an arithmetic sequence. So which means Sn is given as n over 2 into twice a plus n minus 1 into d. I said we're going to use both online and face-to-face. So we're also going to use face-to-face learning. So it's something you need to be aware of. Right, so now we are saying here the sum of the first 40 terms. So the terms are 40, which means n is 40. So this is 40 into 40 divided by 2 into 2a. What is the first term? Is -1 into 40 minus 1. The common difference is what? Is 6. Right, so now we have this, and then we use our calculator to simplify this and get the result. So which means S40, the sum of the first 40 terms is going to be exactly 4640. So which means the sum of the first 40 terms is actually 4,600 and what? 640. 4,640. Right, so we continue now. We're looking at 2.2. On 2.2 now, we're given a sequence and it's said to be quadratic. Right, so 75, 53, 35, 21 is a quadratic number pattern. And we are then saying, write down the fifth term of the number pattern. Write down the fifth term of the number pattern. So we are looking at 2.2.1. And then I'm gonna be seeing you guys with Bupilo there. I'm gonna be seeing you guys with Bupilo. So ready. All right, so 2.2, yeah, 2.2.1. Right, so we're looking at 2.2.1. Write down the fifth term of the number pattern, the fifth term of the number pattern. What is the fifth term of the number pattern? Right, so now it's quadratic. So you have that at this point, you have 75, and then we have 53.
Libo
21. Okay, what is the difference here?
$14.
Okay, you can get the differences.
14.
You think that you think the fifth term is the number 14?
No, the difference is 14.
Oh, well done. Okay, let me raise this one. I want to write correct things here. The difference is, okay, we're saying 53 minus 75, right?
Yes.
And 53 minus 75 is what?
It's 22, negative 22.
Well done. Minus 22. 35 minus 53? Minus 18. 21 minus 35?
14, negative 14.
Well done. Right, so we come here now. What is minus 18? Minus into minus 22.
Negative 4.
We get plus 4. Minus 14 plus minus 14 minus into minus 18. We get 4.
So it's a plus 4, but it's decreasing.
Yes.
Because it's negative 22, negative 18, negative 14.
Yes, yeah, definitely. Yeah, you can look at it that way. Okay, that's okay. Right, so you have the next one is going to be 4 and the next one is going to be 4. You can continue with this pattern. Right, so what is this one that is going to sit here? Okay, because you can see now it's like you have minus 18 plus 4, which is minus 14 plus 4 is minus 10. Plus 4, you can think of it as minus 6, you know? So it's that kind of thing. Right, so if you continue, what is this one here right now? So in other words, you'd have to say minus 21 plus minus 21 minus 10, which is what?
Gonna give 11.
Gonna give 11. Well done. So that is what they wanted. So now they're asking the question, what is that term? So at this point, the fifth term of the sequence is like T5, and T5 is exactly what? It's exactly 11 there. All right. Now in 2.2.2, before I move to Pilo, 2.2.2, determine the nth term of the number pattern. What is the nth term of the number pattern? Right, the nth term of the number pattern. Now we want to find the nth term. Let's do the nth term. And then I'm going to take a break. When I take a break, I give you homework. And then the homework, I'm going to mark it now. All right. So, but I'm going to come then give you juice and biscuits because there are lots of biscuits I bought last time. Is it LO you're talking about?
Yeah, yes, it's
All
hello.
right. All right. Okay.
No.
Right. The nth term of the number pattern. We note that first and foremost,
Let's go. Global. No se requiere lengua. A veces es. ¿Por qué todo reca? What's all good is it?
right, the nth term is an squared plus bn plus c, which means
¿Cuál?
2a is
Baja,
4, you divide through by 2, and then it means a is equal to 2. The next thing is to say 3a plus b. 3a plus b is equal to this guy, and is equal to minus 22. But we can see, therefore, that a is 2 that we know for a fact, so that b is minus 22 minus 6, which is minus 28. Right. One thing that is very important for us to note is that we can be able to see that the first term, a plus b plus c, in the original sequence is this one. So a b plus b plus c is actually equal to this one, 75. So a plus b plus c is 75, which means a is 2 minus 28 plus c equals 75, which means C is equal to what? 2 minus 28, and then we move it across the equal sign, and then we're able to see that C is 101, 101. So, which means, therefore, the nth term, you plug everything into the general formula, an squared. Our A is 2, so that's going to be 2n squared. Our B is what? Is minus 28, so you can actually have that. Okay, so B is minus 28, and then our C is 101, and that is the nth term, because they said the nth term of the number pattern for 4 marks, so the nth term is that one. In 2.3, 2.2.3, okay, determine the maximum value of the following number pattern. What is the maximum value of that number pattern? Right. Okay, you need to look, and obviously it's a very interesting question that is a little bit tricky, but what happened? It looks like it is related to this one, and the examiner just divided by something. They divided by minus 5. If you check this one, you divide 21 by minus 5, you get this. You divide 35 by minus 5, you get minus 7. You divide 53 by minus 5, you get minus 53 over 5. You divide 75 by minus 5, you get minus 15. So yes, we have that. Okay, I'm coming to the kitchen when I'm done with this question, because I'm going to give Tenulu a homework. And then I'm going to start with Bupilo. Mathletes. All right. Now, if you look at 2.2.3, determine the maximum value of the sequence. What is the maximum value of the sequence? Can you see that sequence, and what do you think the answer is?
So I don't know. Must
Okay.
use the convergence formula.
Anything. I don't care, as long as you get the right answer, you know.
Because
But there are many ways to kill a cat, right?
There
are many ways to kill a cat. Never mind. All right. So first and foremost, we must realize something. We must realize something here. that we're going to determine, we're going to look at the fact that what was the shape of the graph here? What was the shape of the graph? In 2.2.2, what was the shape of the graph? Right, we found the nth term. And the shape of the graph was what? Because A was positive. If A is positive, what is the shape of the parabola graph? Because this is like a parabola.
And then the quadratic formula.
Yes, so the shape of the graph is going to be a minimum vertex. It's going to have a minimum vertex. If you divide by negative, then it's going to actually have a maximum vertex. So which means we can get a maximum value, and the maximum value is at the turning point, or it is at the vertex of the graph. It is there or at the vertex of the graph. So which means n is minus b over 2a. Right, so we want to find the n for which the maximum value exists, because it's at the turning point. The formula for the turning point is minus b over 2a. Right, so we have that. But now the thing we're looking at is we do not know the actual formula for this one. We only know the formula of 2.2.2. And then now, what do we do? The minus 5, if you have a graph and you divide by negative, the graph was like this, and suddenly it's like that. But it was like this, and then it becomes like that, but the line of symmetry is the same. What you call the axis of symmetry is the same. So with this, then we're able to see that we can just use this previous one, but we need to be very careful now that we're using a different one. So we need to be very wise. So which means that we have minus. What is our B? Is minus 28 over A is 2, and then it becomes 28 over 4, which is what? Which is plus 7. So which means that the maximum or minimum will occur at n equals 7. It's the 7th term, but if it is the 7th term, we need to find the y value. So, but now we need to find the Tn. So what is Tn? Right, so at this point, we can see that Tn is 2n squared minus 28n plus 101, which means T of 7 is equal to T into 7 squared minus 28 into 7 plus 101. So what is this here? So if you add everything here, use a calculator, you do everything here, it gives what? It gives exactly 3. It gives us exactly 3. So which means that now, but we remember that each term is divided by minus 5. So which means the maximum value what is the maximum value? Right, so the maximum value is that one. What is the maximum value? Right, so the maximum value is this term, but you divide by 5, -5. Divide by -5. So the maximum value is this one. Obviously, it is the maximum value. It is the maximum value of the new pattern. It is the maximum value of the what? Of the new pattern. It is the maximum value of the new pattern, minus 5/3. All right, so now we have tried something, and I think that it's a good time for us to say we need to be with Pupilo. I'm going to be with Pupilo just now. But first things first, I need to send the recording. So